Consider our sequence guessing game, which consists of predicting the next number in a sequence of numbers. We can interpret the sequence elements as data points, which are characterized by its position within the sequence and the number it holds. The position within the sequence is typically obvious or at least easy to determine. We refer to such a property of a data point as a feature. In contrast, the number held by a sequence element might be less obvious. In particular, the number of the sequence element following 8 is unclear or unknown. Such a property is referred to as a label of a data point. Overall, machine learning is a particular form of data processing. By data, I mean sets or collections of several data points. The number of data points can vary significantly between different applications. In some applications, it might be very challenging to collect 10 data points, while in other applications it can be we can easily collect billions of data points. One important example of data are sequences of bits, which might be referred to as digital data. Such bit streams are generated by various sensing devices, such as microphones or cameras. The bit stream of one individual sensing device could constitute one individual data point. However, I want to emphasize that data does not need to be in the form of bit streams. Rather, such digital data is only a tiny subset of possible forms of data. In principle, data points can be any type of object that carries information. For example, data points can be cows. Each data point, such as a cow, is characterized by its properties. Machine learning distinguishes the properties of a data point or divides these properties of a data point into two groups: features and labels. This division is often blurry and depends on the ultimate machine learning application that uses the data points. It might well be that the same property of a data point might be considered as a feature in one application, while it might be considered as a label in another application. Roughly speaking, features are those properties of a data point that can be measured, determined, or computed easily, whereas labels are those properties of a data point that cannot be measured easily and whose determination requires more effort. For example, we could use the birth weight and height of a cow as its features, and the label of a cow would be the total amount of milk produced during its lifetime. Here, the features can be measured easily right after the cow is born. However, the label, which is the milk production, can only be determined in hindsight after the cow is dead. In some applications, it might be useful to compute additional features or labels for a data point. For example, we might add the categorical property productivity to the characterization of a cow. This property could be defined as high if the overall milk production is above 10,000 liters, but low otherwise. A widely used choice for the features of a data point is based on an image that depicts the data point. As soon as we can make an image of a data point, we can use the red, green, blue intensity values of the image pixels as the features of the data point. For a cow, we might obtain an image by making a snapshot using some camera. We might then use these red, green, blue intensities of the image pixels as the features of a data point that are used to predict the amount of milk produced over its lifetime. For some data points, it is not obvious how to make a picture, a snapshot of it. Think about data points representing, for example, the economic condition of a country. However, there is an entire scientific discipline, which is called data visualization, which is devoted to the study and design of methods for creating images of very different types of data points.